Let's take a look at a few problems where we're working backwards. We know some information about the ellipse and we're trying to come up with the equation. So we have find the equation of the ellipse in standard form that has foci at -5, 2 and -5, 8 and one vertex at 0, 5. And I've made a note here that a vertex is a point on the ellipse and it's either at the end of the major axis or the minor axis. So we're trying to fill in for this skeleton version here of the ellipse. And you'll notice that I've left out A and B to try to just not even deal with that. We know that the longer axis, if it's horizontal, will go under the X. If it's vertical, it'll go under the Y, and so on. So we'll just try to fill in what we can figure out. Well, I've graphed the things that we were given, and one thing that kind of stands out to me is I know that the center is going to be right in the middle of my foci. So my foci are 1, 2, 3, 4, 5, 6 units apart, confirmed by going from 2 to 8. So my center should be right in the middle there, 3 steps in each direction. So my center, HK, is located at -5, 5. Alright, well, that gives me the numerators of these. So x minus -5 squared is the same as x plus 5 squared. Y minus k, y minus 5 squared. And I know, of course, this is going to be equal to 1. So what's left to figure out is what's going in the denominators here. So this denominator, what's under the y, has to do with how far up and down I'm going. What goes under the x has to do with how far right and left. Well, if this is the center and the vertex is 1, 2, 3, 4, 5 steps to the right, that's the denominator of our x part. So that should be 5 squared, which is 25. Because remember, that's the number that tells us how far to the left and right to go on our ellipse. Okay, super, great. Now we need to know how far up and down, but we don't have either one of those endpoints. Well, we do know that it's the major axis because the foci are always on the major axis. And we also have this relationship that c squared, the distance from the center to a focus, is called c. C squared is equal to the larger denominator minus the smaller denominator. If c is the distance from the center to the focus, we can see that that's 1, 2, 3 steps away. 3 squared is equal to. The larger denominator is the one that we are looking for because remember the foci are in the same direction as the major axis. They're up and down. That's what we're looking for. So I'm just going to put lard in, larger denominator, minus the smaller denominator, which is 25. So 9 is equal to the larger denominator, terrible variables there, minus 25. And if we add 25 on both sides, we get 34 is the larger denominator. So 34 goes down here. And we have the equation of the ellipse with these characteristics. Now let's look at a couple of word problems. But we're still going to have the same task. Write an equation for the ellipse. So we've got this arch in the shape of the upper half of an ellipse to support a bridge. So if any of you future civil engineers, you're going to be some bridge builders, this is all for you. The river is 20 meters wide. The center of the arch is 6 meters above the river. Write an equation for the ellipse in which the x-axis corresponds with the water level and the y-axis passes through the center of the arch. Okay? So many times we will conveniently locate the center of these things at 0, 0. It just makes it so much nicer. So guess what that means for the numerator of our ellipse? X squared and y squared. Okay? Well, we actually have points on the ellipse. So, how far are we going to the right and left of our center? Well, if the whole distance is 20, then this distance is 10. So 10 is the denominator of my x term, and that is squared. I'm going 6 up from the center, 6, and squaring that will go in the denominator. So this equation is x squared divided by 100 plus y squared divided by 36 is equal to 1. Then we have something about a whispering gallery, and I don't know if you've ever been to NC State. They have a whispering wall out by the D.H. Hill Library. That's the old library, not the brand new, gorgeous, beautiful one, but I encourage you to go check it out. So a hall 100 feet in length is to be designed as a whispering gallery. If the foci are located 20 feet from the center, 25 feet, from the center, how high will the ceiling be at the center? So we're trying to figure out how high to build this ceiling for this whispering effect to work. Well, I've just oriented it horizontally because that just made sense. And we know that the total length is 100. So the end of our ellipse is 100. So from here to here has to be 50. And then here to here as well has to be 50. Let's think about having an x and y axis going right through here. We have the nice setup that way, again with the center being at 0, 0, where we have x squared in the numerator and then y squared in the numerator. Always equal to 1. Alright, so the foci this time are horizontal, which tells me my horizontal or my x direction is the larger. I know that this was 100, so from here to here is 50. The denominator of my x term is 50 squared. Well, the whole question is how high to make this ceiling. So I really ultimately need this information, and I'll be able to figure that out. So I will think about the foci information that I'm given. I know that the foci is 20, the distance from the center to each focus is 25. That's my C. So 25 squared is equal to the larger number, which has to be 50, squared minus the smaller denominator. All right, well, 25 squared is 625. 50 squared is 2,500. And then smaller denominator is just really not what we're going to be using. I'm going to call it b. And of course it is b squared. So if I want to solve this equation for b squared, I would subtract 2,500 on both sides. And when I do, I get negative 1,875 is equal to negative b squared. So that would mean b squared is equal to 1875. Well, that tells me this denominator is 1875, which also gives me the information about how high to make that ceiling, because it should be the square root of 1875, because that's how far up and down, up is really all we're interested in, we go from the center. The square root of 1875 is approximately 43.3. So we should locate the ceiling height in the center to be 43.3 feet high.